So I'm Marc Weber at the Computer History Museum here on February 21st, 2023, and I'm helping Robert Garner interview a panel of distinguished Alohanet principals. We have Frank Kuo, who is the co-PI with Norm Abramson, and then David Wax, Alan Okanaka, Chris Harrison, and Richard Binder.
Thank you for that introduction, Mark. So first of all, I want to say what a great privilege and honor this is to be able to talk to you guys all at once. About a year ago, as part of my project looking into the history of the Ethernet, I happened to be visiting the CHM with some ex-Xerox PARC people, and one of them, Ron Ryder, said, when we were looking at the Alohanet exhibit, said, the person I'm in the facility with is Frank Kuo. So that was my first contact. And then Frank, you knew about perhaps that Richard was in California, so I was able to find Richard. And then Alan, you were in Hawaii, I was able to find you on the phone. And then Chris, I was able to find you on the phone. And then Chris, you gave me a hint to find David Wax, because there are too many David Waxes in the world. Being up in Washington. So over the course of several months, I was able to contact all you guys. And then we've had phone exchanges and email exchanges. And Frank, a couple of months ago, said, hey, why don't we do an oral history panel of these four guys? Because they did all the work. I mean, it'd be fun to do that. So I followed up on Frank's suggestion and organized this. For me, I started my project on Ethernet history thinking that I would just cover the period at Xerox PARC and after that. But, how could I not leave out the inspiration of Alohanet? I mean, we know that Bob Metcalf read about it I have the thick proceedings of the 1970 AFIPS proceeding, read Norm Abramson's paper, which inspired him to write a paper that was published in the 6th Hawaiian International Conference on System Sciences on his way to maybe control slotted Alohanet when it starts to get too busy. And of course, he went on to actually adopt the random access broadcast method at Xerox PARC. It's interesting that. And then, of course, later by 1980, it became the Ethernet standard. I always thought it was interesting that the ALOHA System reports are kind of this robin's egg blue. Xerox PARC reports are blue, and the Ethernet spec is blue. So there's a tradition of the color blue here, guys. So I thought, so I've talked to Frank a lot, and Frank last month discovered his diary that he had written from 1968 or so to 69. And he went through it, and he and I talked about it for an hour and a half or so a couple of weeks ago. But I thought that it would be good, now that he has all this remembrance and details, if he could maybe talk about the origins of the beginnings of the ALOHA System project in that time frame. And then after that, I've got just some idea questions to go through each one of you. We'll do that in order, and then we'll open it up to group discussion at the end. So that's kind of the agenda. Frank, do you want to kick it off with your revitalized memories?
Okay, it started in 1968 in January with the Hicks Conference, the Hawaii International Computer System
Sciences.
System Sciences.
Yeah.
That was the first Hicks.
You started those, right? Frank, you started those.
Yeah,
right?
Norm and I started it, and I was the first chair. Anyway, it was a big deal because everybody wanted to come to Hawaii in January. So among some of the people came was the people like Howard Frank and Len Kleinrock. And they were members of the Arpanet project to begin with. And so they thought it would be a good idea to have the ARPA principal investigators meeting, they have quarterly meetings to come to Hawaii after Hicks. And so they wanted us to provide a conference room, which we did in Holmes Hall. And that started it in, say, mid-January. And all of the principals from the original Arpanet project came. And Norm and I were not members. And initially, they didn't even invite us to be there. But we insisted, since we were the hosts, it would not be a nice thing to avoid, to not have part of us there. Okay, there.
Now, and Frank, this was January 1968?
Yes.
Yep, okay.
Okay, and so around mid-1968, they have a 2-day meeting, and Bob Taylor, who is the head of IPTO, and Larry Roberts came, and a number of the principal investigators meeting people came. And Bob Taylor then talked about the idea, the initial beginning of IPTO, which means Information Processing Processing Techniques Office, which started in 1962. And the idea, the main goal was the IPTO was to build a reliable, survivable computer network for the military. So the idea of survivable and reliable was very important. And so he talked about that, and then Larry Roberts, who was the program manager for ARPA, talked about the new Arpanet. And his idea was that it's a demonstration project to connect some of the largest computer that in different large computer networks together using Arpanet. And he talked about that, and then he then talked about the idea that he learned in 1967 in an ACM meeting in Tennessee, and he gave a talk about networks at that meeting, and at the same time he met Roger Scantlebury from England, who talked about packet switching, and he talked about the fact that he learned packet switching from Donald Davies. And so that's the first time that Larry Roberts learned about packet switching. And so after the talk, he and Roger had a long discussion about the fact that in the future, packet switching would be everywhere. And so Larry had to learn more about packet switching before he thought that would be the way Arpanet would go through. So he spent the next month or two learning about packet switching, and actually learned about the Paul Barron's work, which was done in California, but it was a project that was a military project. So
was that the RAND Corporation?
Yes, RAND Corporation, but he could get access to that information. So as a result, in January, he told about the packet switching, and that's the way things are going to go with Arpanet. And so I thought in that two-day meeting, Norm and I learned both about Arpanet, which we had never heard about before, and packet switching. And so we decided that we would do our own network. We were not invited to join Arpanet, by the way. And we would do our own network, and we would use packet switching. But we would not use landlines because we thought that Hawaiian Electric landlines were both too expensive and also unreliable. So it was sort of a natural thing. And the fact that we in Hawaii have different islands. So the goal was to perhaps connect all of the computers, which is many computers with different islands, to the University of Hawaii IBM's 360-65. So that was a goal, just like Arpanet, but with radio. Radio was the main idea. And so for the next 6 months, a group of us with Wes Peterson, Tom Gardner, and Shu Lin, we met quite often to talk about the difference between radio and landline, and the fact that we only have 1 or 2 channels. And we also talked about the fact that we could not use the IBM 360 to do the packet switching. So we needed a mini computer to do that. So I think Norm and I were the 2 principals, but the others really helped, especially Wes Peterson in the beginning. But after it became a project, the others did not work too much. And then, let's see, we had to learn more about using mini computers. And it turned out that in the summer of 1968, I went to a EEE awards board meeting, and I arranged to go to BBN in Boston, in Cambridge, to meet for Frank Hart. So Frank was very friendly, and he introduced me to Bob Kahn, who was the real manager of the project. Bob and I knew each other at Bell Laboratories, where he worked briefly for a year or 2 after Princeton. And so Bob showed me about the IMP, and I didn't know what the IMP was because IMP meant no meaning to me. And he told me what an IMP was. Okay, so I learned that, and so we had dinner together, and we became good friends. So I told him about our project. He said that would be very useful to Larry Roberts, and he knew Larry Roberts pretty well. So in the September of that year, we had our ideas pretty well in hand, and so we asked Bob Kahn to connect us to Larry Roberts, which he did. And so we went to the Pentagon. And so we walked to the Pentagon, walked into the E-ring. At that time, there was no guards. There were no guards. So we went to the E-ring and found it pretty easily. You know, he was like, the E-ring, by the way, is a top military people there. Then you go down to the D-ring, which is, when I went, I had a place in the D-ring, which is pretty high, but then you go down. Oh, well, anyway, E was pretty big deal, and I didn't know that. And so we met Larry Roberts and Bob Taylor. Bob Taylor was very friendly, and Larry Roberts was kind of cool. So and then Norm and I pitched the ideas, and Norm started about the radio, and I talked about mini computers, and they got pretty interested, you know, almost right away. And we went through about 2 hours and looking in details. And so initially, Larry Roberts wanted us to have the project built by BB&N. He said they did a really good job. They are really doing a good job with Arpanet. Why not having them do the same thing? It'd be real easy. And we, both Norm and I, did not think that was needed, and we fought very, very hard.
Apparently, Norm.
But Bob Taylor was very amenable, and Bob Taylor was Larry Roberts' boss. So that worked pretty well.
Well, apparently, Frank, Norm got a little defensive because there was an implication that you guys wouldn't be capable of doing it, and Norm kind of put his foot down.
Absolutely, he didn't think too much about UH. And so we were very defensive because, you know, when we went to UH in 1966, the department was a very small department and didn't have anybody. And so essentially we were the stars, and we wanted to show that we could do something for Hawaii. And so we did. By the way, he went to he was coming from Stanford. He was an associate professor there with tenure. And I came from Bell Laboratories, which is a really major research laboratory too. So we had to show up something, you know. And we were both theoretical people. And so we needed to work with engineers to help us build this project. But of course, we didn't tell ARPA that we didn't have the capability at that time to do that. And this is why you guys are here, because we needed you guys more than we needed anybody else. We didn't, and by the way, we did not have a radio guy in the department, you know, and so we needed somebody like Dave Wax to come in to help us. But anyway, we were very persuasive, and they liked the idea of radio. Was really a great thing. So before we left, Larry Roberts said, you know, if we give you the project, we want you to take the BCC 500 over to Hawaii and continue to build it together, because there was apparently it was in in a company that was going to go under. And BCC 500 originally came from Berkeley, so it had really got a lot of great starts, but it needed to be finished. And he suggested that we invited Wayne Lichtenberger to help build the project. And Wayne Lichtenberger, and Norm didn't know Wayne at all, but Norm and Wayne Lichtenberger and I started as freshmen at the University of Illinois. And so I've known Wayne for a long time, and how brilliant he was and how dedicated he was. So I was very, very willing to bring the BCC 500.
And apparently Al Perlis was friends of Larry Roberts.
Right. Mel Pertis.
Mel Pertis. Right.
Well, so the names go, but anyway, it went so smoothly. Within a few months, we got a project, and so we started to, I guess, early 1969 to be the project. Norm and I were co-project managers, and I would be the project. I would be the project manager, and we would both be co-PIs. And so we started that then, and then we started hiring people and learning more about how we're going to build this, and so it's up to you guys to do it. So I'm finished here.
No, that is great. That's amazing, Frank. You summarized an hour conversation into just 15 minutes. That was really nice. That's a remarkable story and how it all connects, because that hasn't been really told before. So now I thought the next phase you would go through each of you guys in order, but I probably won't give up on Frank quite yet. You know, your role as principal, it was more than just the PI role. I think you, Frank, would you say that you did a lot of the management and organization and, let's say, hiring of students? Was that kind of your role?
Yeah, well, actually, Norm and I actually hired most of you guys, not just me.
Yeah.
But I actually spent all the time working about the money projects, and I also worked with the theory and the project work. But you know, Norm also did that, but he wasn't just a theoretical guy. He worked also with a number of you, and he also went surfing, and I never surfed.
He didn't hold it against you. All righty. And about when did you leave University of Hawaii?
When did I leave University of Hawaii?
Yeah. When did you?
82, but I left several times to work with the Pentagon.
Okay.
Because I worked with the Office of Naval Research for a year in 1971, 72. And then I worked in the Pentagon itself with the Office of the I was called the Office of the Professor, not Professor. I was called the Director of Information Systems in 76, 77. It all began because I was good friends with Bob Kahn, and also I worked with the Navy in ThinkPack. So I was more connected with the military than Norm was.
Okay. And then my last question.
Yeah, and then in 82, I was still working. No, I went back to Hawaii, but half of my time was in Washington. So I spent a lot of time traveling. And in '82, SRI offered me a big job, and I was thinking about it. Maybe that would just travel half. It would take half my travel down, and that's what I did. It was I really liked working with SRI over the years, and so that was the best thing to do. So I left in '82.
Okay.
I was 48 years old, and I gave up my tenure as a full professor in Hawaii. And we loved Hawaii.
Yes.
But we had to do something for my travel.
And in 1972 or 3, you and Norm had time to do this textbook on computer communication networks. You guys were the editors of this.
Absolutely. It sold many. Oh, I couldn't show it. I couldn't show it.
Yeah.
Well, anyway.
Yeah.
The
And then in
80, yeah, it was Prentice Hall.
Yes.
And it had all of the opera people contributing.
And then
So
in
it was
81,
really-
you did this book.
Right. I did a lot of books together.
I noticed.
But I'll tell you, the two projects, this project and two of my books, the things I'm really proud of.
Okay. All righty. So thank you very much, Frank. That's amazing. So I thought what we could do now is go in the order of Richard, David, Alan, and Chris. Richard, do you want to go first and talk about how you got involved in the project to begin with and how that all started?
Okay. Well, I had decided in the fall of 1968 to go back to school and get a master's in computers, since that looked like a good field to move into. So I proceeded to do that in September or so of '68, had a class from Norm in something, I can't remember what it was. And I also had a class from Frank a little later on. And around, well, in late spring of '69, Norm asked me if I wanted to work on the ALOHA project, whatever that was. I had no idea what it was going to be all about and so forth. But so I said, sure. And so the summer of '69, I was on it full force. I was a student for about 2 years or so, even 3, because I stayed on for a while doing something else. And then became full-time on the project around maybe '72, somewhere in there. So that's how I got into the project. And then I worked that summer of '69 under, really under Frank directly, who guided me in what I was asked to do. And also,
What did you think the goals of the project were at that point?
Oh, I'm not. I can't remember if somebody said these are the goals of the project. I'm sure they did. The first exposure in the project was at the beginning of the summer of '69. There was a project meeting. That may have been the first full project meeting with all the different students on board and so forth. There were 3 or 4 others, Charlie Bass, John Davidson, 2 or 3 others, I think. And so there was a meeting to talk about the project. And the memories I have from it are Norm giving a presentation of curve he had developed, which appeared in the 1970 paper, on the behavior of random accessing channel, including its congestion and instability points and so forth, and talked about that. And that was most of the meeting, I think, the discussion of it. My first task that I was subsequently asked to do.
Can I ask you a question there?
Yeah.
Yeah, it's interesting. You do recall in that very first meeting, he understood that the network could become locked up and that unstable points. Yeah, but he never wrote about it in any of his papers.
Well, he maybe avoided writing it in that talking about it in the 1970 paper. He did include the curves, and
but they always cut off right when it starts to go
right at the max point of goodness. But at that meeting, we talked at length about the instability of the channel, the by-point operation, and all of that. So, in any case, I proceeded as my first task. I was asked to design the positive acknowledgement protocol for the channel. And I think it may have been Norm handed me a paper from communications of the ACM by, I don't remember who, on the 0-1 bit protocol, acknowledgement protocol. And I proceeded to implement that or design it in detail for the system. It was actually a special case of go back in, but at the time it was mod 2 scheme. They just called it 0-1. And then proceeded to also design the packet formats. The rest of them, there wasn't much else in the way of protocol at that time other than the random accessing, of course, channel itself. But I proceeded to do the packet formats in conjunction, as I recall, with Alan Okanaka, who was designing the TCU, and we wanted to make sure the bits in the header were reasonable for him to be dealing with in the right place and so forth in the hardware. So let's see, I did that, and then also at some point during that summer, I guess, probably Frank introduced me to the HB 2115, which was going to be the Maniuni, the central controller of the for the channel. And I was tasked with developing the software for the Maniuni. So I proceeded, and also I think Frank had asked me that first summer to pull together bits and pieces of what Alan was doing, what the guys on the 360 side, Davidson and Charlie Bass were doing, to run it all up in that first document in 69, multiplexing in the Aloha system.
Which you found a copy of in Microfiche somewhere.
That's right. Dug that out and now online. So I did that, and that's how I spent my summer vacation, as I first titled that report that I wrote up.
Hey, before you go on the summer, you mentioned that you may have had some memory in that first summer meeting of some student suggesting the name Aloha.
No. My understanding is that somewhere I've seen from either Norm or Frank's oral histories or wherever it was that came from Wes Peterson, but I don't know. It was pretty much a given, I think, in 69, as I remember it, when I got involved in the project. But it's an acronym.
My diary, and I didn't find anything about Alohanet or anything like that. And maybe it was developed. It was thought about at that time, but I didn't write it. I didn't write it down, so I don't know when it happened.
Yeah. Yeah, well, it was called the Aloha System. In fact, it wasn't until maybe a couple of years later, I started pushing to use the term Alohanet because I thought that was a much sexier term than Aloha System. Well, I always liked Aloha System and pushed that. But in that fall of '69 write-up that I did, we did use Aloha System. And I think I even spelled out what the acronym stood for in that report. So somebody fed that to me.
Yeah, yeah, it was Aloha System. Alohanet came afterwards.
Right, right. And then, of course, I was continued to be a student for a couple of years, and particularly those first 2 years, 69 and 70. Once the summer was over and classes started up again, that was my primary concern. As I got into programming, developing software for the Menehune, was that started sucking my, that was hard to not be doing that, whatever my class demands were. But it was otherwise pretty much summers for those first 2 or 3 years.
But by the way, just to go back to that name again, so in case people forgot, that later someone forced the name Additive Links Online Hawaii Area System.
Well, that was around by the time I wrote my that first report at the end of the summer of '69, because it's spelled out in that report.
Yeah.
So I don't know where it came from.
Someone made it up. No.
Yeah.
I thought it came.
Yeah, go ahead.
I thought it kind of came from Wes, but I'm not sure.
Okay.
So Robert, I don't know how much further you want me to take this at this point. I continued to, once I developed the software for the Menehune, did you want me to talk about that?
Yeah, talk about that a little bit if you could. Yeah.
Okay.
I have a question there too.
Okay. Well, as part of the project, Wes Peterson guided a grad student in writing a compiler for the project for the HP that I am pretty sure was a subset of PL1, since that was IBM's dominant language at that time for their stuff.
Didn't HP have a language you could use already?
I don't know. I knew nothing about computers. This was a mini computer. Okay. And by the way, it had 60-bit words and a whopping 8K memory size. And that's what
That's big actually for that time. Yeah.
8K. Right.
Yeah.
Well, actually, 2 or 3 years later, when the Menehune was, when a 2100 was obtained to replace that with, it had about 32K, I think. So much larger. So I wrote the software, proceeded to debug it using teletype. One of the very nice things that happened was as part of bringing up the interface between the Menehune and the IBM 360 TSO, time sharing system, a part of that TSO interface for Aloha had the capability of downloading the programs directly into the Menehune through the IBM interface machine to something that connected the two up. So we were operating through an I/O channel provided by IBM, standard I/O stuff that was connected between the Menehune I/O ports and the 360, for which John Davidson was, while I was writing the HP code, John Davidson wrote a module to reside within the 360, which provided an Aloha interface to TSO proper in the 360. Charlie Bass was also involved in this, but I'm not sure how much his fingers got dirty in that particular place. But he and John would both worked on the 360 side of that. But John in particular wrote that software to multiplex, use the Aloha users coming in through packet switching through the HP into the 360, which of course knew nothing about packet switching or multiplexing lots of users coming in through this single pipe. So let's see. So the downloading of the program was really a very important thing, because even though I still had to work with punch cards, lots of fun to drop them once. You never do it more than once.
You forget the paper tape.
Huh?
Remember the paper tape?
Yeah, but I don't recall ever working with paper tape, because we have this download capability directly from the 360 into the HP.
But initially you had to, in order to get the capability into the hand loading the loader, I remember. And I think you did some paper tape, a little bit of paper tape work to get booted up.
Probably had to do that. Yeah, I don't remember. I have no memory at all of touching paper tape. I do remember the punch cards and of course the printouts, the program, debugging it all, and then finally having it ready and downloading it into the HP.
Yeah. So Richard, you were way ahead of your time. The idea of downloading the software is only something that came to the rest of the industry much later.
Yeah, I don't know who was responsible for actually deciding to do that.
Yeah,
probably Wes Peterson is my guess.
It was very innovative for the time. Very innovative, actually.
But it allowed just that very fast turnarounds.
Yeah.
Paper tape would have been.
Well, that's what the rest of us were doing on mini computers: deck tape, paper tape. Yeah.
I was involved in some of that also, because
Great.
I went and on the Kanekioki made a download program that would download from the HP to their satellite network from real tape, and that we were feeding paper tape into that machine for 30 minutes to reestablish the satellite network, and we were able to do it in 30 seconds after we figured out how to do that. So downloading, ALOHA System did a lot of that. I did it and Dick did it, and as I'll explain later on, I did it with the PCUs and the repeater.
Okay, great. Okay, let's hold that. So, hey, Richard, I got a question. So in your multiplexing report, remember I found this section where you were considering a corner case where if the remember, everyone knows there's two separate channels. The kekis or the terminals had one frequency going up and the Menehune had a different frequency going down. So if the Menehune was, if a keki was sending a long packet to the Menehune and the Menehune was sending a short packet to another keki, if the Menehune was going to, if the kekis were going to acknowledge back to the Menehunes, their acknowledgement would collide with another keki and immediately cause a collision. So you decided to not have kekis send ACKs, which kind of made sense because it wasn't a shared channel anyways, but you were going to keep the carrier up, kind of like a busy tone.
Yeah, I'm not even sure if I got into the carrier, but and I think Dave has elaborated on that with a better idea. But as I pointed out, in fact, even in the introduction or abstract of that report, that we decided to keep acknowledgements from users back to the Menehune to hold off on that and leave that as a subject for further research, because it was clear that that was going to mess up the channel if we started doing that. And yeah, as part of writing that up, I threw out some little idea about we could play some little scheme, but that was part of a much larger research topic, which we didn't actually follow up on. We never, in my time there at least, implemented a acknowledgement scheme for that. I think there was some that happened with Chris's what was the name of your the program?
PCU.
Huh?
PCU.
PCU, yes, yes. For downloading files into the PCUs, for example. But,
Well, I think,
but that was not part of the Aloha channel stuff.
Yeah, I think you made the right decision in having the user kekis not send back ACKs. I mean, that was the same decision that Metcalf made later in the Ethernet. I think a lot of people forget that the terminals, were transmitting on one frequency, receiving on another. So they really couldn't do carrier detection because they'd have to add a second receiver
Right.
at the other. So that was out of the question. So you had to do acknowledgements or the lack of acknowledgement to detect collisions. So you couldn't do carrier sense and you couldn't do collision detect in the other ways.
Yeah, well, and that was all very deliberate because the goal was to, for that first implementation, to implement pure Aloha. Unslotted, simple Aloha, where if the user has something to send, he sends it. So we had to really have separate, and also we had the much heavier flow of traffic coming back from the 360 as well, another factor. So we really needed the two separate channels.
Yeah.
At the user terminals, TCUs, they did not need to be full duplex, and they were in fact half duplex, I believe. But at the Menehune, it really had to be full duplex with those two frequencies in order to do simple Aloha at that point. Otherwise, we're talking about time division stuff in a single channel, and it's a whole different ballgame. So that is Norm had coined a phrase at some point in maybe a few months after that. At some point early on about calling it the system 3/4 duplex. That was kind of shot down. Didn't catch on at all.
Let me add in that when we came to the repeaters, that was truly two channels, and they had to repeat both on the broadcast channel as well as the incoming channel. So that was an interesting thing.
Yeah, that led Richard to have to put a large gap between Menehune transmissions, so you wouldn't step on the next transmission.
Sure. Well, the Menehune actually, the terminals themselves were dumb. The TCUs, which is what we're talking about in the original context here, were all hardwired and expensive to throw in different functionality into it. So the Menehune was responsible for spacing packets to the user terminals such that through the TCU, so that any timing considerations that the dumb terminals required, I don't mean that disparagingly, they were dumb, would work properly. In fact, there was and after I don't know how long it was, a couple of years, I think initially we had just the Model 33 teletypes, but then those were solely replaced for a lot of people with dumb CRT terminals, which were blooming at the time. This is what, 71, 72 timeframe, I think, maybe 73.
Very expensive.
Yeah. Plus, I remember there was one unique terminal pretty much in the original system that was a graphics terminal, and it was Wes Peterson's baby, I think, where he had.
Yeah, I remember that.
The MLAC.
MLAC, yep.
Okay,
MLAC.
and and Wes really wanted to use this thing, so the Menehune fed data over to that. And it had, of course, its own special timing characteristics as well. And the CRT terminals had their timing characteristics different than the teletypes. So, and the Menehune had to be responsible for all of that. Was not a really big deal, but it, had to have some tables and stuff and do that bookkeeping. So
Yeah.
that's where we're at.
Yeah, you had to basically implement, flow control based on the type of terminals. When Bob Metcalf visited later in '74, he commiserated with you because they had discovered the same problem at Xerox PARC between Novas and Altos. If you didn't do the flow control just right, the Altos would miss packets. So I think he was commiserating with you that you had discovered that already. So I have one more question for you. You told me the story about how, speaking of Metcalf, how when you visited at Project Mac one time, you might remember the date because you got a postcard. Can you relate that story again?
Yeah. Well, actually, I meant to look up that postcard because it has the month and date and year on it that I mailed it back. That's when we were back there. Let's see. The context was that Norman asked me to go back and give a paper at some local regional IEEE meeting up in New York in the Catskills, I think, on his behalf because he couldn't do it. And I convinced him that John Davidson ought to go with me. John and I were fellow grad students and we worked together a fair amount, took a fair number of classes together. And the objective was that after being up in New York and doing that, we would stop at BB&N on the way back and pick their heads to learn good stuff about what we were doing out in Hawaii. So we did that. And while at BB&N, David Walden was showing us around, and he took us over to the MIT Multics lab, show us that. And as we're walking around through the lab by the Carrolls, Bob Metcalf is sitting at one of the Carrolls reading my 1969 Aloha multiplexing report. And with its nice blue cover and everything. And so I, of course, got a big kick out of that. Here's my little report from Hawaii in the MIT lab being read by somebody. Now, why do I think that was Bob Metcalf?
What was the date again then, do you think?
Now, I believe that was in early '72.
Yeah.
And I didn't go back and look at the postcard, but I believe it was early '72. Pretty certain it was 1972. Now, actually, Dave Walden might have set that all up just to laugh out of that all, but I don't think so.
Yeah, because Metcalf's story is he didn't learn about it until he was handed the report by the IETF guy at his apartment in Boston.
Steve Crocker.
Steve Crocker.
Steve Crocker, yeah.
Yeah, well, I might be mistaken. It might not have been Bob Metcalf sitting in the Multics lab.
Yeah, I'll ask him.
We did have him around there, I believe, at that point in time. And but in my head, it was Bob Metcalf, and I think Dave Walden, because Dave Walden introduced him as such.
Yeah.
Otherwise,
Sure. I'll definitely run it by him.
Yeah.
All righty. Well, anyways, I really appreciate all the documents that you've been able to find and make available and answering all my questions over the last year. Should we move on? Is that good for now? Okay, we'll get all back together again. All righty. David, do you want to take it from the top about when you joined and what do you think your role was supposed to be? Actually,
Yeah. Hear me okay?
yeah, you look great.
Good. Well, I was finishing up some graduate work for my master's in the fall of 1968. And when they put the PhD program in EE department, they added an option for the master's program. It used to be you had to write a paper, you had to do a dissertation, and when they started the PhD program, they allowed you to do just an oral exam and 12 hours extra coursework, graduate level coursework. Well, since I was a working guy at that time, that was an obvious thing for me to do. And so I was finishing up my last hours in the fall of 1968. And I was working for a company called LTV. They're a big aerospace conglomerate. And they had a little research lab or research center there in Honolulu. We were supporting the Navy on anti-submarine warfare. And I was working on a lot of underwater acoustics analysis and stuff like that. But I took a leave of absence to finish up that I guess that was a semester, wasn't it, at U of H? And in preparation for taking my master's, and so I did that, and then I had my oral exam in January of 1969, and Norm Abramson was one of the guys on the committee who did my oral with me. And actually, I specialize in automatic control. I didn't specialize in communication theory, but I'd taken a couple classes from Norm. I took his course in communication theory and also one on coding theory, and found him really interesting. He is a great teacher, and anyway, after my orals were over, Norm approached me, and during the orals, I sort of explained that, I was an experienced engineer. I'd, been working as a electronics engineer since 1954, 55. And had a fair amount of experience, large with a little bit with Boeing and also quite a bit with Honeywell in Seattle. So anyway, he was sort of interested that I had this background. I was a design engineer. I knew how to do circuit design and everything. And so after my oral was over, he approached me and said, he's got this project he's wanting to get going. And he said, called it the ALOHA System. And would I be interested in joining it? And at the time, I said, well, I can't really, because I'm on a leave of absence from LTV. And then, I got to go back to that. And, and I was on a regular engineering salary and things like that. And I had a family to support. So I said, I'll go talk to my boss. And so I went talk to him, and turns out that the money was winding down from the Navy and they're going to be closing up shop. So that sort of set the decision for me. And so I went back to Norm and said, yeah, I could come on board. And he said, well, I'm getting some more money in from ARPA. I think you're actually funded on Air Force money at the time, as I remember. Yeah. Is that right, Frank?
Yeah, Air Force money first. It's called.
Yeah, and then you got the ARPA money.
Right.
Yeah, well, Norm was, I guess he was pretty certain you were going to get the ARPA money. And so he said, well, I'll set you up with, a regular salary equal to about what you're doing now. And I said, wow, okay. And so I started in September of 1969 is when I came on board to the project. I don't know, about a 6 months lag there from the time I took my master's until I reported on board. And Norm, he had sort of explained the basic idea of Aloha to me. I thought was sort of really interesting. With the random access channel, he told me it's going to be a 2-channel system, and it made a lot of sense to me. And really, what he was interested in, of course, was the random access channel, which is the whole thing about, you know, multiplexing many computer users onto a single radio channel. So he wanted me to figure out how we're going to do the radios and the modems. And so I sort of looked at it, and I sort of saw that it's very similar to what we have in regular mobile radio communications, and so I thought, oh yeah, and the other thing was that Norm really wanted to get the system up and running as soon as he could. He wanted to demo it. And so I figured, well, we'll just adapt some mobile radios and just to get this thing going. You know, back in those days, they were all tubes, and I bought a couple Motorola base stations, and first we had to hash out what band we're going to get, you know, and of course, you know, we're asking for 100 kilohertz bandwidth channels, and of course the FCC just said, what? You do not do mobile radio on 100 kilohertz channels. You do well at UHF. They allowed you to have 30 kilohertz. Well, 25 kilohertz spacing, I think it was. Over the years, it kept going down and down and down as they try to pack more channels in. But but there were radios then that had 30 kilohertz IF bandwidths. And
David, before you go to the radio, did the frequencies that you guys selected, 407 and 413 megahertz, Larry Roberts had something to do with that, asking the military for those frequencies?
They were Air Force military. They were Air Force.
Air Force.
Was it the Air Force? I thought it was ARPA that got them, but
no, it was Air Force.
Really, I didn't know that. I thought Larry Roberts was the one who got them for us.
No, we had a Siemens project with the Air Force, and we got some projects there.
I didn't know that.
Yeah.
Well, originally, we went into the regular UHF mobile band, and of course the FCC went ha ha ha, and so that's when ARPA or Air Force came to our rescue and said, okay, we can give you these government bands, in the 406 to 420 megahertz band. And so that's how we got it. And then they gave us a couple frequency assignments.
Right.
And I don't know. Do you remember when that happened, Frank? I don't remember clearly. Around 69, 1970 maybe, or must have been.
Around 70, I think.
Yeah, I think it was. So that was my biggest concern, was just getting frequency assignments
But once you got them, as I understand, the frequencies are so close that you had to buy a high-end Lenkert unit that it was.
Well, if you want to run full duplex, you got to have some pretty darn good equipment. That spacing was only about 6 megahertz or so, 6 or 7.
Yeah.
And that at UHF, that's not easy to do.
So you basically had to buy a large rack-sized Lenkert.
Well, for the Manahoney, I knew that I was going to have to get a common carrier quality radio. And Lenkert was in the business of making them. I knew Lenkert because they supplied a lot of equipment to Y&Tel. And
this was
so
I
knew the guys at Lenkert.
And this was a tube-based unit.
Oh yeah. Well, the stuff was sort of getting a little hybrid about then. We were getting they were getting some solid state stuff into the radios, but all the power stages and everything like that are all tubes, yeah. And so Lenker, that's why those radios cost us so much. That tight spacing with 100 kilohertz wide channels, Lenker did that. And because just keeping the transmitter power out of the receiver, you got to have some, really super duper diplexers in the front. So they did that, and of course, the common carrier people like Lenker, that's their business, is building these very linear channels, radio channels, and because you don't want to generate any more intermodulation products than you have to, and any nonlinear aspects in there will do that. So for the full duplex requirement at the Menahoney, I went to the Lenker. We didn't have to do that for the Keiki, so because we could do half duplex for that. So we didn't have to transmit and receive at the same time. But the Menahoney had to do that. So it got the expensive radios. And I think we bought 3 of them, and I think Richard, you had one of them, I think, hooked up to a mini computer, as I remember. It was a long time ago.
Lockheed Sioux.
What?
Lockheed Sioux machine.
Oh yeah, that's right. And then the other 2 were used at the Menahoney. One was hot and one was in standby, so that we could maintain the channel. And then of course for the first time we went on the air, I used a modified Motorola base station, and of course that's push to talk. And
you mean in the user terminals, or are you talking about in Menahoney?
No, not the. Oh, pardon me. I'll take that back. We didn't have the Lenkerts yet, so I used a regular push to talk base station at the Menahoney, and for a while there, Richard, you had to operate on the basis of you couldn't operate on a full duplex basis because I couldn't give it to you. But we only had the Menahoney and a Keiki, so that wasn't any great problem. I mean, but I remember you had to jigger up your code so that we could do that. Are you talking?
What about the Kekis now, David? What were the first radios on the Kekis, the station?
Well, the first Keiki was a Motorola push to talk radio, as I said.
On the user station, on the user stations, I'm asking, on the Kekis.
The user.
Same radio, you're saying?
Yeah, the TCU. You use the radio.
The first radio, just to get the system up and running, was a Motorola base station.
Okay, so what, you're saying including for the TCUs, but okay, what was the second one for the TCU then?
Then after that, then came the TCUs, and we didn't use the Motorola. I mean, yeah, we didn't use the Motorola's very long. It was only a few months until we could get other equipment in, and then let's see, I'm trying to remember.
In the TCU, did the radio unit go into as one of the cards in the TCU, or was it external to the TCU?
It was built into the TCU, as Alan will probably
okay
remember.
And
we-
did you design the modem as well, card for the TCU?
Yeah, the modem was one of the TCU cards. There are 5 cards in there. 4 of them was Allen's logic, and the 5th one was the modem. And then against the back plane, we in the back of the TCU, we mounted the RF equipment, and some solid state RF equipment was coming out about then, and I was able to buy it, buy the pieces and get the power amps and the IFs and
So you bought those as separate stages and assembled them in the back of the
yeah,
TCU.
we bought them as separate pieces and put it together.
I know you have a complete report on it. I'm just doing this verbally.
Yeah,
I've seen the
there's a
report.
report describing it. I don't want to go into all that
Right.
gory detail, but
Right.
we did we bought pieces and we made some of our stuff and we bought some of our stuff. Because, for instance, the IFs, I was running pretty high gain in the IFs, and so I did a double conversion on that. And but I bought just a standard FM strip, that it was a solid state design, and then I designed a special 30 megahertz first conversion amplifier, and then we dropped down to 10.7 megahertz. And that, when you do that, you can keep the IF stable. Otherwise, you start getting so much gain in it, the thing will sing on you.
Now, for the modem, can you talk about the modem design?
Yeah, actually, the modem design was influenced by chance and by stuff I learned from Norm. When we did the original setup with the Motorola base stations, I had to have a modem. We're running FM, that's the modulation that was available in those radios, and but I had to figure out a way to handle the data, and I could have gone to like frequency shift keying or something like that, but the problem is there are the decision levels that have to be made, because if you're using the FM or something like that, if you're using FSK, you've got slicing levels that you have to worry about. You have to worry about DC offsets and all this kind of stuff. And it was the crystal oscillators were nothing compared to what we have today. They were good, but they just didn't have the accuracy that we have today. And so I had to worry about the offsets out of the discriminators. And so I decided to just do an end run about that and use a subcarrier in which we could just AC couple and not worry about that. And it was just really practical stuff just to get us up and running.
What was did the next version use phase shift keying?
Pardon?
Did the next version do phase shift keying? I always thought that you did phase shift keying, differential phase shift keying.
Well, I'm talking about FM for the RF modulation.
Okay. What about the?
So the reason we went to differential bipolar phase shift keyed data modulation was, for one thing, again, expedient. There are a number of manufacturers putting out wireline modems that were using DPSK. And so I bought a couple of them, put one on the Menahoney and put one on the Keiki, the original. And they worked pretty good, but they were designed for wireline, and they're somewhat error susceptible. So I figured I was going to have to improve on that. So when we did the TCU, I designed our own modem, and that was designed to protect the data as much as I could, because the way the TCU operated, well, I guess, yeah, the way the Menahoni and the TCU operate is that you sent the first 1 bit you sent was the beginning of the packet, and that's you have to worry a lot about false alarms for noise when you're doing that. Otherwise, you're sitting there in check all the time. So I had to, design the modem with a receive gate on it, and so I had to be able to detect when I got the modulation, the 9600 hertz signal. And so, I don't want to get into all the details, but, we use phase lock loops and stuff like that to detect when we had coherency. And then I'd send a signal out to Alan and say, okay, it's all yours. But I wouldn't release it to him until I was sure the channel was down to, I think I set an error rate about 10 to the minus 5 or 10 to the minus 6, something like that.
Wow. Okay. All right. Well, that makes me think of a question.
Yeah, you had to do that. Otherwise the TCU would be sitting there checking the channel all the time.
Yeah, Dave, Dave, you may want to mention something about the carriers coming and going, and the challenge of synchronization of the incoming, and how many bit times it took to synchronize and so on.
Yeah. The subcarrier approach allowed us to do synchronous, and when you do synchronous, you can do a lot of good stuff. Actually, I designed a digital version of a integrate and dump builder on it, and you base it a lot of theory just on what I learned from Norm, and so we're able to get pretty good performance out of that modem, And then we had phase lock loop in there to acquire the phase of the signal, and so since the TCUs were listening to the Menahoni all the time, I could design in a very narrow band phase lock loop on that. So even if you got a disturbance, it very likely would not lose lock. And so that's later on when we got the repeaters, then I had to modify it for a fast sync modem, which was basically what was in the Menahoni. The Menahoni had to be a fast sync modem, because of the burst nature of the data coming in.
A lot of challenges.
So we had to change the TCU modems a little bit to accommodate the repeaters.
A lot of challenges. I just had one last question. Do you recall ever, like in a lab environment, having two kekis sending at the same time to your receiver on the Menahoni to see, whether you had a capture effect, or to see whether collisions were actually detected?
Actually, with a pair of TCUs force a collision.
Yeah, did you ever test that?
No, I don't think we did. Did we, Alan? I don't recall that we ever did that.
I mean, it could be that your receiver was so good that if one was, even though they're both transmitting at the same time, if one was closer, you could have captured the signal of the collision.
One of the things about using FM is the fact that you get capture effect. Actually, I got a double, because I used I did hard limiting not only on the FM, I did it on the phase, on the subcarrier too. So you got a real waterfall effect, and you know, all you needed was about a couple dB, and you were error free.
Yeah, so I think it's conceivable. I've said this, you guys can think about this, but I think it's conceivable, you know, since there are only about 5 or 6 TCUs ever built and PCUs ever built, that a collision may have never occurred in the airways of the Alohanet project.
Oh, I don't know if we ever did, and I don't know. Richard, did you ever collect any data? Or? I don't think so, huh?
Well, he's muted. You're muted, Richard.
You're muted, Richard.
That's what happens when you follow instructions.
You can say unmuted.
Anyway, without some special aid through probably a separate interface from the hardware from Alan's unit or possibly you, Dave, it was pretty hard for the Manihuni to determine if there was a collision or not. The Manihuni just had a 16-bit register with words coming in and interrupt every time 16 bits came in, and then plus the checksums, both header and data checksums. And I forget what the convention was, Alan, that if the checksum had, in Alan's, in the TCU had checked bad, forget, you wrote all zeros or something in it, something like that, that told the Manihuni that it was a bad packet. So
how many checksum errors did you record?
yeah, we did certainly record that, but
did you remember getting any checksum errors in the history of the project?
sure we did. I'm sure we did, but no, I don't remember it. But you know, we had some counters in the Manihuni to collect simple stuff like that. But as far as whether a checksum was bad because of channel noise or collision, Manihuni really didn't have a way of determining that.
Okay.
Yeah, didn't your Lockheed Sioux do a lot of simulation for collisions?
I thought you did.
Yeah, but that was not actually in the channel. That was simulated.
Yeah.
Okay, David, any more thoughts? And we're going to move on the radio side of things. One question I had is, the thing always ran at 9.6 kilobaud, I believe. Norm tended to write 20 kilobits per second. That was like a goal, but I guess.
Yeah, I know. Well, you know, originally we were talking 50 kilobits per second, but we never got there because, well, we had receivers that just didn't have the bandwidth, and we just couldn't handle that data rate. And actually, 9600 was about as much as I could reliably get through these. You know, these receivers, the maximum bandwidth on them was like 30 kilohertz. After we built our own receivers, you know, the ones we used in the TCUs, we did build those for a full 100 kilohertz bandwidth, but we never changed the data rate. We just left it the way it is.
All right.
Yep, and we never investigated quadrature encoding or octal encoding or higher levels of encoding.
No, I mean, my marching orders, as far as I was concerned, was to get an operating system up. I mean, really, it's the random access channel was what is to be proved. And I wasn't trying to come up with any fancy modulation schemes. I was trying to build it with what we could get readily and get up and running. And I figured later on, if we got funding and so on, we could go play those games. But at that time,
yeah,
wasn't
well,
interested.
the whole ARPA packet radio project went on for a decade later, exploring that entire space.
Yeah, they're the ones that really looked at it, and fine by me. I mean,
it was a huge project.
That's a real can of worms, and
it was a real can.
It's still being explored today.
Yeah, it was a massive project back then. It's good you guys didn't get sucked up into it. Okay, anything in your last thoughts, David?
It was the greatest project I think I've ever worked on. I really had fun. You know, usually working for some company or something, you get deadlines and all this crap that you have to deal with and so on. But this one was, Norm said, here it is, go at it. And as an engineer, it was probably the most fun project I ever worked on.
Wow.
Well, where did you go after Aloha?
I went back to Honeywell in Seattle and returned there. I didn't go back to the phone company. LTV was gone. They're only there for a few years. And so that was what I decided to do. And it was okay. And I spent about 5 years with Honeywell, and then I went back to Boeing, which was the company I originally worked for right at the start. And
I think before you left, you worked on the ATS-1 project, right? The satellite ATS-1.
Oh yeah, I forgot to talk about that.
That's okay. just a project you
Well,
worked
I
on.
just going to mention, I think that was a project proposed by NASA Ames, I believe, but probably steered that way by Norm, if I know him. But it was really their project, and they built all the hardware and everything for it and shipped it out to us. And so we were playing games on that. We were experimenting. That was really interesting. I found that quite an interesting project.
Yeah. Okay. All righty. Well, let's move on. If everyone's doing good. Alan, do you want to go next? When you joined and what the goals of the project were, all that kind of stuff, what you did?
Okay. I came to the project after being in the Army as an electronic technician, maintaining, installing, and repairing fixed crypto equipment. It's a highly classified piece of equipment, but at that time, the drivers, it was like a hybrid tube and solid state. It was between the two. The memories, bit memory was on a magnetic core about the size of your thumb, and there's a whole bunch of vacuum tubes in there. Huge power supply that generated a lot of power. But, we worried about everything from the proper grounding, shielding, all the way up, and my job was to maintain everything up until the information was passed over to the single sideband radio system that the communication center had. So I had a lot of experience in putting packages together of different types. And after I got my bachelor's electrical engineering, I worked for AdTech. I don't know if you folks remember AdTech, but it's a company put together by Dr. Roloff and Dr. Weldon, Ned Weldon, and I forgot Roloff's first name, but it was a truly garage electronic company. And we had two products. One was a educational training system for logic, and the other one was for customized systems. So, the only one I can remember is they wanted a way to measure the reflex when somebody taps your knee to know whether there's a proper reaction or not. But there are other customized electronic systems that were put together by AdTech. And when this Aloha project came around, Dr. Weldon and Dr. Roloff convinced me that this is something that that my expertise was needed, and I could do it. So I got interested in it. So I joined in 1969, about the same time as David. I think you were there already, David, when I came on board. I understood what was needed. It was easy for me to visualize what the system would look like because I was familiar with a whole bunch of other electronic equipment. So putting it together was a matter of knowing what the system requirements were, what the power supply output has to be and how much power, the shielding and everything like that from the radio system. But the thing that I didn't know was that there was no such thing as a terminal control unit in the marketplace. And that meant, and I did a lot of research, and there was nobody making anything like that. I couldn't go to a Radio Shack and pick up something and slap it together. The microprocessors were in its infancy, right? And I think it came about in 1974, I think, right, Chris? About-
73.
Yeah. And so here we were in 69, and we had to use discrete TTL logic to put all these things together. The most sophisticated circuit, integrated circuit we had was a flip-flop. And so it was all pieced together, and it was a lot of fun because, it's like coming to work every day and trying to think, okay, what new problem am I going to run into? But I enjoyed it. Interestingly, I don't remember why we did this, but they requested that we build an interface between the ASR, the teletype ASR, the teletype unit. And, I'm starting to think that that was what Richard used to interface with the HP 2100.
That's correct. That's correct.
That's correct?
Yes.
Okay. That was a daunting task because, as you know, the teletype runs on electromagnetic coils and all that kind of stuff for their data. So to convert that into digital pulses reliably was a very challenging task. Well, we did it. We got that going. Then working on the TCU. The TCU was a buffer between the terminal and the radio system to packetize information. We had both full packets of 80 and half packet of 40. The header was 16 bits, and I think there was we designed a polynomial of 16 bits to make sure the header was correct, and then another 16 on the data so that the data would be correct.
Did Shu Lin help you with that CRC?
I'm sorry?
I think you told me a story that Dr. Shu Lin helped on CRC.
Yeah, that was a fun meeting because we just sat down and used we used his book. I forgot the name of the book. Frank, you remember the name of the book that he wrote on error correction codes?
The coding theory, yeah. I asked him to write that, and I helped him a lot.
So we use exactly what was in that book in order to design the circuitry to create the polynomial for error detection up until 3 bits, I believe. We could go up to 3 errors.
So this was Shu Lin's book, not Peterson's book?
Yeah, no, it was Shu Lin.
Peterson had this book on error correction codes.
That doesn't look.
No, that's an early book.
Okay.
Shu Lin worked for
Right.
Wes Peterson,
And his first edition of his
his
book.
book came out in Prentice Hall around 1970.
Oh, okay.
Yeah, yeah. In fact, I took a course from him, and so it was fun to take something out of the book and actually design something that would go into a system.
He said you recalled he really enjoyed that.
Yeah.
It was 3 error detection and possibly one bit correction, but you did not do the correction part.
We didn't do the correction because the circuitry got kind of horrendous, and it would also have a delay to transmit the well, if there was no delay, it's fine, but if there was a delay and for error correction, then it delays back sending that information to the terminal. So besides the TCU, which is really a buffer unit, I designed the I call it a concentrator, but all it was a random access scheme by hardware to a single TCU. In other words, you could put up to 8 terminals randomly accessing one TCU to get to get on the air. And we thought that would be a real practical way of using a single instead of having one TCU for one terminal, have 8 terminals connect to one TCU. And we got that implemented. I don't think we had 8 terminals connected to it. Put the repeater together. And Richard probably.
But before you go on to the repeater, one thing I found interesting in your TCU design is your memory was a 640-bit shift register.
Mhm.
There were no SRAM chips that you elected to use. You just
No.
actually shifted it all the way through.
No,
Yeah.
the 2102 was the first SRAM chip that came out, and that was in 73, 74. That was a big problem.
Yeah, so you needed to have, you probably used a whole bunch of 8-bit shift registers there. I could see how the chip count would go up.
And
Yeah.
those were the most sophisticated TTL integrated circuits at that time, you know.
Yeah.
So
And one thing I thought was interesting is that because you only had this fixed register, you would, well, you guys called, you would lock the keyboard. And now I realize that meant that you didn't echo back to the teletype. So the user may have been typing, but nothing was echoing back. So it would have the effect of a locked out keyboard.
oh yeah. So you don't get it. I'm getting all mixed up.
Yeah. So in essence, you had some good, flow control method. Now, the other thing that was interesting looking at your design, because David Wax had saved that paper you wrote back then, was that you only did 2 retransmission attempts.
It could be more, but we felt that after.
Oh, it was 3? Okay.
Yeah, it could be more than that, but we just set a limit to that.
And then you had some kind of random pulse generator. What was that?
We found this interesting circuit. I don't remember where I saw it, but we found one that generated random occurrences based upon some bad circuitry. In other words, you use a bad capacitor, a bad resistor, bad inductor, and it generates these crazy sequence that never repeats. So I can't remember what it was, but I thought it was a very novel way of getting random access information.
Up to about 1.5 seconds, according to what I've seen.
In our Army system, we use the Fibonacci chain, which and the Fibonacci chain was programmed with a set sequence of 1s and 0s to start off at a different location. I mean, a different initialized set of data. And as you probably know, the Fibonacci chain will take that one set and then generate random pulses. Well, this one here was it's a bad electronic circuit that generated random pulses.
Why was there a need for randomness in the Army system?
The Army system, the Army system had it's part of the encryption scheme.
Oh, I see.
Yeah, and it's.
I got it. Yeah.
They kind of warned us about what we can say and cannot say.
Right. I got it. That's enough information. Yeah. Okay.
Yeah, part of their encryption scheme.
Right. Okay.
And then we put together that 50 kilobit line between the Menehune and the 360 that went through their NFA system. I can't remember that it was the humongous chassis. 1830, I don't know. Anyway, it's one of those IBM numbers.
Right.
And that one there, we didn't want to pay for a leased line. So all we did was get wires between Holmes Hall and where's that with IBM was sitting in, whatever. Holmes. Anyway, and Holmes Hall.
Where was that, Chris?
Geophysics. It was on the second floor geophysics, something like that. It's the third.
Yeah, wherever that 360 was sitting in. So we just blasted that thing with. So
did the wire go along the sidewalks or something? How did you?
It went through there were conduits connecting the building.
Okay. Yeah. By the way, I just pointed out the original system.
We could.
The original system that came later with 2100 and Holmes Hall, but the original system, the Many was located in the computer center.
Yeah.
Just outside of the 360 room.
Mhm.
And so that wasn't a part of it then.
Yeah, when you moved the Menehune into the Holmes Hall, we had to have that wideband circuit over to the thing. But it was a very simple, no sophisticated protocol or anything. It just blasted the signal right through, and it worked. You know, it was cheap and it worked.
I remember you did that. It just, what do you run around 50 kilobits or something like that on it, didn't you? 50
Yeah.
kilobits per second. Yeah.
Yeah,
Yeah.
it worked.
Just straight wire line and no compensation or anything.
No, and it didn't. Well, I think we were the only ones using that bundle for one thing.
Mm.
And the thing is that, you know, like I said, the transistors drivers that we used were
Yeah.
heavy duty ones. Yeah, I think they were designed to.
Yeah. Yeah. They had those wireline drivers.
Yep. And you used NRZI also.
And overall, I had the responsibility of keeping the lab as a lab, hiring people, making sure we had the right equipment. Every year we sat down and figure out how we're going to buy all this electronic parts. The University of Hawaii has a system where if you get an amount, you gotta get 3 bids.
Yeah.
Usually when you go with that kind of 3 bids, you can end up with a supplier that has inferior components. And then, so that means you might buy 100 components and 5 of them or 10 of them would not be good. So we have to come up with very,
Yeah, I got a story on that one. When I bought those Motorola radios,
yeah,
they went over the cost threshold with the university's procurement department.
yeah.
And well, we ended up anyway on paper splitting those radios up into 3 parts so we could buy each one separately to keep under the cost threshold.
That's a very,
Get away from the red tape.
that's a very common technique used to this day. Yeah.
It's been 50 years, so I'm sure they're not gonna come after us. But that's exactly what we did for a lot of the components. We split it up so that we could get below the written bidding.
Yeah,
You know, it was a hassle for that. The
it
university.
really was.
So Alan, you were telling me that when you were debugging, I don't know how long it took you to debug your TCU, but you were telling me that you were thinking you would have liked to have you contacted HP or something for maybe some logic analyzers and
Yeah, we worked with the local HP guy a lot because they're kind of on the forefront of digital circuits and systems. And I wanted things like a bit inserter or a packet inserter. And, you know, we had a bit inserter in the Army. All it was a small little thing that like a flashlight, and you connect one to ground and the other one, you click it and the bit gets inserted into one of the logic cores. I wanted something very similar to that. And nobody made those things. You know, I wasted my time going through all these companies looking for something like that. So we finally ended up making those things, and we made about 3 or 4 of them. And it's very simple. All you got to do is you touch your probe over to on a flip-flop, and it'll convert that 1 to a 0 or 0 to a 1.
Yeah, I've used them. And also you were looking for a logic analyzer of some sort, but they didn't offer one yet.
Well, it was more I wanted a packet generator.
Just a generator, not an analyzer. Okay.
Yeah. We wanted to be able to key in a packet, and then insert that and send it in. So that way you don't have to have a terminal and, you know, press the key.
Yeah, actually,
did they make one? Go ahead.
Well, actually, we had such a device sitting there, the HP 2115, in that original system, which if I had been more savvy, I could have written little software and we could have used that. Yeah, in fact, it's too bad Chris wasn't on the project at that point because it was probably right up his alley. But I remember you guys both debugging your hardware in that initial thing at the computer center. I'm not sure where your stuff was. And we weren't making use of the HP at all, which we should have with hindsight.
Yeah.
Did they ever supply a packet generator for you, Alan?
No, they never did, but later on they came up with a bit inserter. I don't remember. It wasn't very expensive, a couple of $100, I think.
Well, packet generators became a big product for many companies in the, at least by the late 80s, by the early 80s. When
Not when we started.
Oh, but I'm thinking that you guys may have put the idea in their head.
I suspect that's what happened with HP, because even like the bit inserter, about a year later, they had something like that.
Yeah.
And so who knows? Like I told you earlier, we had no idea that some of the things we designed and built were patentable, and it was kind of frustrating for me to hear that some of the circuits we designed were actually somebody had patented.
You said you got the TCU working in the middle of the night. You went out to have a celebration dinner, and that was it.
Yeah, that was a fun thing, because when the TCU first worked, my lab assistant and I were the only ones in the lab, and it was exciting because it actually did something. And so we went down to Kunia Simon shop about 10:30 in the evening, and we had Simon, and that was our celebration. The next day, of course, we made sure Frank and Norm knew about it. But that was a really exciting moment. Of course, on the other side of that thing was, there were a lot of nights that I sat there looking at the TCU and knowing that if this damn thing didn't work, this whole project wouldn't work. So a lot of pressure.
Yeah, I think people forget how much pressure are on us engineers in those situations, because it's easy enough to write about it and do simulations, but it's another thing to actually get it to work.
Right.
So congratulations.
And I remember Alan played poker with Norm and I and other groups.
Right.
Every Friday.
Yeah.
In other people's rooms, houses. I had some in my house, and then Norm had some poker places in his house.
Yeah.
You were a good player in those days.
Well, you came over to my place, I know, several times, and
I see.
some of the real interesting stories out of it. It's Norm was the best bluffer I ever had. He can bluff you with a straight face so well, and we got caught in that trap.
Right.
Yeah.
I still play poker.
Yeah.
Once a month. And
Wow.
I can lose up to $50 and win $50. But I'm old and I lose more than I win.
Very good.
So why do you think Norm was such a good at poker face?
I think
he's an extremely clever guy. I mean, how did we win the project manager from ARPA? Depends upon Norm a lot.
Yeah.
When you think about it, it's probably he got trained by convincing a lot of funders to fund the Aloha project, and I'm sure there are a lot of moments when he really didn't know what he's proposing is going to really be funded. And
right, of course.
Yeah. That's a great skill. Yeah,
I think poker plays a lot of role in that.
Yeah.
It should be an undergraduate requirement. Okay, any other thoughts, Alan?
The only other thing is the ALOHA system was recognized by a lot of foreign countries. And for some reason, Frank and Norm decided that I would be the host. And so when the Japanese engineers came through, I had to sit down with them and patiently explain with their broken English and my broken Japanese. Well, I can't even call it broken because it's not even Japanese. But anyway, we had to do that. I was very proud when the first time Chinese journalists from mainland China visited the United States. They decided that one of the things they wanted to see was the ALOHA System project. And they came over, sat down, and I found out, I thought they couldn't speak English, and I found out they spoke flawless English. It was very, very embarrassing for me. You know, I think I told Pete in our training, I mean, earlier that I thought if I spoke slowly and I spoke loudly, that my English would automatically be translated into. But that was a very embarrassing moment. We had guys from either Hungary or Turkey. And
Hungary.
was it Turkey?
No, it was Hungary. Norm went to Hungary.
Yeah. But we attracted a lot of attention. So it was worldwide, widely known. We tried to convince the state of Hawaii, I believe, right, Frank, to fund our project, and it never took off. They didn't see any value in what we're trying to do. So
Did you actually try to do that, Frank? Actually try to convince them to fund a network?
Not really. I mean,
Just gave up.
we had so much money, we didn't.
But Frank, you didn't have enough to build like 50 stations around the islands, right? So
No, actually, I wasn't really interested in that because I thought we were just a demonstration project, and we made it, and the people, and we became famous because of that.
it was enough, yeah.
Yeah, that's enough. I mean, the stuff we built was huge. We couldn't put it all over the island.
yeah.
Yeah, it would have been a much bigger project.
Right, right.
Okay. Well, it's happened now. Here we are, 2020s, and here we are talking video from Hawaii to California.
But you haven't talked to Chris.
Yeah, Chris is next. Yep. Okay. Anything else? Anything else, Alan?
No, well, I should mention that we also worked with Lawrence Livermore Labs and the Stanford Research Institute. Lawrence Livermore Labs were interested in using our system to measure average wind velocity over a given area. And so they beamed the laser beam from Tantalus down to Leahi Hospital. And we didn't get very far with that because it didn't work the way they wanted to do. And the other one was with Stanford Research Institute, a couple of professors or engineers, I can't remember what their titles were, but they came down, and what they wanted to do is to have the remote capability of anywhere and gathering scientific information. And so the target was the Haleakala crater. And that pushed us into trying to get a repeater up there, but we never were able to get a reliable path back to the 360. So that went as far as connecting up with the astronomy group, getting permission to set up equipment, use their system, use their electricity, but we never got farther than that.
Yeah. When
But
we
you
ever
did go, sorry, but you did go up there. I remember reading, right?
Yeah, we
Install
did,
something.
we did go up there, and we actually hauled the equipment up there and try to get it going.
Okay.
I thought we did run some tests from up there, didn't we? I mean, as I recall, we had a really very good path, but that wasn't from where you wanted by the rim of that was actually from the astronomy building up there, I think, wasn't it?
Yeah, we used their utility building.
Yeah.
set up.
I remember I provided you a Yagi antenna for that.
Yeah.
Yeah,
You had a good link from the top of Haleakala to the repeater in the hospital, but
Right.
but maybe some other aspect of the project didn't work
well,
out.
then you had a link from there. You had to couple from there over to the what was that, the National Park building, which was right by the rim
Yeah, it's the
of the
visitor.
equator.
The visitor center is right on the rim, and we looked at the bathroom building, which looked like we could have installed a Yagi from there back to.
So maybe what David's saying is the link from there to the Diamond Head Hospital, whatever the name of that hospital was okay.
Yeah.
But maybe there was some other problem from the top of the crater into the crater or something, or
Yeah. Well,
Yeah,
you got to be out at the rim because the crater drops very rapidly from the rim down.
right. Yeah, I'll be there in May, by the way. And I've been in that building you're talking about. And a friend of mine actually worked there for a while. Okay, yeah, we'll talk about the deployment when we have our group discussion about where all the repeaters and stations were, but let's move on to Chris. Chris, you still there?
Yep, I'm here. You hear
Okay,
me?
so when did you join, and what you think the goals were? And it's all yours.
Okay, well, let me go back a little bit and
Okay.
state that I'm kind of a technology freak, and you know, before I went to elementary school, I was always interested in radios and so on, and transistors when they came out. I remember buying one on my way to school when I was in 7th grade. That was in 1958, and I got my amateur radio license back there in '59, and going on, went to UH and co-founded KTUH, and I was slowly responsible for the technical side of KTUH, getting it on the air. And in the process of getting it on the air, I built some line transmitters because we weren't able, we had to fight the Regency, the Regents to get our license. So I built some carrier current power line transmitters to the dorms that they were using. And we finally got a license, and I got my FCC first class commercial there in '68. And then after I graduated at UH as an engineering student, Noel Thompson of geophysics got me very interested in repeaters and radio and amateur radio there. And I didn't know very much about FM 2-meter repeaters. And they had one set at Diamond Head, and they had also a repeater set up on Haleakala and Mauna Loa. And they were all linked at 400 megahertz. And we were able to communicate with our handhelds pretty much anywhere on the islands, over the islands. And that has been terminated. The links have been terminated, even though they're possible by the politicians here that said, oh, we don't want the islands interacting with each other and so on, radio communication. We only want it in the case of emergencies. So going on from that, I was working for Noel Thompson, the lead engineer there at geophysics, and he had a SPC-12 mini computer. And I got a chance to work with that and hand code code. He had the teletype machine. And he also got a Hewlett-Packard machine, 2114, I believe it was, for satellite communications that we're going to put on the boat. So I got to play around with that. And I remember just had the hand code because the assembler was a 3-pass paper tape assembler, which answers one of the questions of what you could do. Back then, there was assembler available for Hewlett-Packard, but it was on paper tape, it was 3-pass, and it was horrendous. So anyway, I learned about I had known about the ALOHA system and learned about it by a lot of people that mentioned it, saying, oh, interesting project. Why don't you go over there? You got talents, you know how to code, you know about electronics, you know about computers, mini computers, and so on. And so even my boss, Noel Thompson at that time, who hired me as a technician, even though I was a graduate engineer, he said, oh, we have a position, will you take it? And I said, sure, because I wanted to get my hands dirty. I love the UH, I love technology. what was going on. And so to make a story kind of short, Norm Abramson got word of me and said, "Oh yeah, we'll take you on. We'll take you on. Come on over and help us with radio and computers and so on." And at that time, there was no microprocessors. Again, like Alan, I was playing with 64-bit shift registers, and most of them were dynamic, which means you had to keep shifting them or the memory would go away. We had flip-flops and various things, and that was about it. But I had got the shift register from a corporation called Intel, and I heard that they had the 4004, and I looked at it and, oh yeah, it's a calculator chip, pretty nice little calculator chip. So I didn't think too much about it, and I went over in 1972, about, I would say March timeframe, and I moved from geophysics to the ALOHA project. And of course I met Alan, and I knew Alan from before because we had a class together, I think with Frank Kuo. But so to go on, I got interested, and I was kind of delving around, looking at the TCU and the radios, and met Dave Wax, and Dave and I were talking about radios and so on, and having a good time. And I didn't really have any goals at that point. And Frank Kuo stepped in and said, "Oh, we'd like you to go to SRI in California." And so I went, and I got trained on the Deck 10 there a little bit, but I was interested in Intel because I knew they had some pretty interesting stuff coming out. I heard about the 8008, and so I drove over there, and I just popped into the front office of Intel, and I talked to them, and they showed me this little proto board, which had an 8008 on it, and I looked at it and I said immediately, lights went off. I said, "Hey, I can use this as a part of a preliminary programmable control unit." And so I called Jeannie back and I said, "Can I get a PO to get one of these things?" And they worked it out. It was about $300 or something like that, or so. And we got it. I got to bring it back, and I sat down with a teletype, made it talk to it. And also the thing that came about at that time was Intel had just introduced a 1702 EEPROM, which was a big memory unit, 256 bytes on a chip. Oh my goodness. It was a tremendous, Alan and I were looking for memory, and here it was. It was not only that, but it was permanent. You want to go away when you turn the power off. So I got some of these, and I sat down with a little radio. I don't think I had a radio. I had a connection to the 2115 at that time, and I connected up, and I made it talk serial to that 2115, and then I was able to do that with the 8008. But the trouble was too slow. I couldn't do any parity checking or anything. So I remember I just wrote the code, hand coded it, just to pull the packet in, ignore the CRC check, and just throw it on the teletype, and it worked. So after that, Dave and I got together, and we got a radio. We conjured up a radio from somewhere, and we made that work. And I was reading on Intel, and I said, "Oh, they got a 8080 chip coming out. It's not available yet, but let's see if I can get one, because it's so much better and faster than the 8008, and the code is pretty compatible." So I wrote them, and we were able to get a sample chip for $360. I remember that. It was very expensive, but we got one of them, and I was able to wire wrap up a board, and I needed memories. 1K by 1 were the biggest memories, power hog memories I could get in a 16-bit chip, and got 8 of those, and eventually became times 4 to give me 4K of memory, which went away, of course, when you turn the power off. But I had 4 of those fabulous EEPROMs that 256 bits each, and put 4 of those together to get 1K of memory, which was a big deal in 1973. And from there, I was able to write code, hand coded it, hand loaded it, got it into the EEPROM. The way these EEPROMs worked, if you made a mistake, you had to take them out and you had to cook them for 30 minutes to erase the memory. And then you could put them back in and reprogram it again. And so you don't make too many mistakes. So what I would do is I coded a little bit of a bootloader, we called it that, into one of these things. And I loaded my test code into the read-write memory, the 2102s, which I had about 1K worth of them. And from there, I worked on it and I got myself enough code in one of these 256-bit codes, EEPROMs, that I could talk through a radio and pull over information, store it and pull it over and communicate. So that was the start of the PCU. From there, being an amateur radio operator and so on, I had some friends here in town, and they told me, I had this little Sankyo 400 megahertz radio that I got from Japan. And I asked this guy, well, can you make one of these things? Can the company in Japan make one of these things for our frequencies? And he said, oh, sure, they probably should be able to do that. So I talked to Dave about that, and we ordered, I think 2 or 4 of them, I forget. We ordered 1 to start with. We got it in and it worked so well after Dave went and puged up the IF, because the IF was narrow banded down, would never let the data go through that we needed to go through. But he winded it up and we put his fast sync modem on it, which he had developed by that time. And from there, I was able to package it up into this nice little PCU package, stuff the power supply in the back. I knew that there was a lot of heat in there at that time, but I thought, oh, well, it'll work, and it did. And bolted the radio to the top and coded it up, and we got a programmable control unit. Some of the neat things about this unit was that I ran the code in the volatile memories because I wanted to be able to change it. So I talked to Dick and I said, hey, I need to be able to store an image on the Hewlett Packard machine so I could download the code to run this thing on request. And so we did that, and we had a downloadable programmable control unit, probably the first one in the world that did that. It was downloadable from the Minahuni. I'll call it Minahuni, but it was a ALOHA Systems control unit. And from there, somebody decided, oh, we should build a repeater. And Dave and I talked about that. And I said, well, it's got to be full duplex. We got to be able to send and receive both channels at the same time. And I used one computer chip in there. And I had to go and build into the hardware the ability to check for the packet being correct. And I decided, well, rather than syncing on the first bit that came in, I was just going to take in 32 bits and shift them through and check until I had a correct header and call it a packet. So that opened up odd, even packet numbers, which we never used, but this unit was able to sync on an odd or an even header, first bit. It didn't require the first bit. It sunk on the full 32 bits with the correct CRC in it. And that was all done in hardware. And I built 2 of those, one for incoming, one for outgoing, and made it. We got a duplexer in there, which was not too expensive and fairly small because it was a 400 megahertz duplexer, and it worked very well. And where to go from there? Any questions at this point?
Oh, sure. I got one for you. So I was just checking. your 8080 costing $360 is $2,700 today, inflation adjusted. So one question I had though was, did you ever consider using a bit slice like the TI 181?
Yes, too much power, too many chips. I did look at a bit slice machine. In fact, I was going to order one in 1975,
Mhm.
but the company that made it did it. Maybe I was too naive or whatever. The price looked too good, and it was too good.
But I was thinking you could take the 181 and just build your own little CPU, so to speak, with your own microcode and whatnot.
Yes, but as I said, too many chips, too much
many chips.
power.
Okay, all right.
It made a lot more sense to get a 8080 microprocessor and use it.
So how did you
You
handle
use-
how did you handle the CRC calculation? You told me, but I can't remember.
Okay, a bit at a time, and it takes a lot of time. You got to shift each bit in and exclusive OR it, and move it in and out of a register.
But it was fast enough you could receive the next packet coming towards you?
Well, the problem, 9600 baud
Yeah.
and the speed of the processor chip at that time allowed me to do just about one parity check while I was DMAing or interrupting and throwing the rest of the packet into memory.
Okay.
So while I was doing the CRC checking, the system was also getting interrupted in the middle of those checks and putting the next byte in. And there was as long as it wasn't, there was 2 or 3 bytes behind it or there was some delay, there was no problem. And that again brings up another issue that, there was some sync time when the carrier came up. The radios didn't sync on immediately. So there was at least 10, 15 bits. And I know Dave didn't mention too much about it, but it was a real issue. Because in the repeater, everything is packetized, everything comes in and goes out. I have to be able to receive on the incoming and the outgoing channel symmetrically. And it didn't matter which channel was which, the code was identical. So it treated the broadcast channel just like the incoming random access channel.
On the repeater, did you ever consider listening for carrier? I mean, another packet before sending?
I didn't have the ability to listen. I only had the ability to see the data shifted into the registers and whether it checked. The header checked. If the
You
header
didn't have a separate signal from David's circuitry saying carrier is here.
No, I did not. I could have, but I did not.
Okay. Because ironically, I've exchanged this story with David. I've talked to Fouad Toubaghi, who was the student under Len Kleinrock, and he first thought he heard of the idea of carrier detect from a repeater discussion in Dallas in 1972, probably with Norm or something like that. So it must have been a hypothetical thing that Norm was thinking about or something.
Well, it was discussed, and just like Norm used to say, well, we use the 4040 to start with. Well, the 4040 is a calculator chip. We never use that.
The 404, you mean? Yeah, right.
The 4004 or 4040, whatever. They had 2 different chips that came out. The 4004 was the first one out. It was designed specifically for a calculator. And the 8008 was the first general purpose chip.
So you do recall Norm thinking about whether repeaters should do carrier detection?
Not really. That discussion came and went, but it kind of went one in one ear and out the other.
Okay, all right. Yeah, it worked fine. So there was really no need to. So I could see how it would be a theoretical question. I mean, Richard was intentionally putting a long delay after every transmitted packet to give you time to resend so that his next packet wouldn't collide with the thing you're sending.
Yeah, actually, I don't know. He didn't really discuss that, but it wasn't necessary because it was full duplex and I could receive a second packet after the first.
But the one you're sending might interfere with the next one he's sending. You see, when you're repeating.
They're 2 different frequencies, and
One,
Oh,
no,
that's right. You're right. You're right.
Yeah.
You're right. Yep.
Yep.
Yep. Yep. You cannot send 2 packets back to back because, well, let me think about that.
they can be back to back, but the fear is that you got one coming in and you're sending it out, and Menahuni is now sending another one, and there could be a Keki that could receive both your repeater output and Menahuni's output, and then that they would collide. So I think
That's correct.
Yeah.
That's correct.
I think Richard, you put a delay in there. Is that
Yeah.
right? I'm asking Richard.
Yeah, probably, I don't know.
Yeah,
I think that's most likely written up somewhere.
yeah, I saw it. Okay.
Political document or something.
Okay.
Yeah.
Keep
There
going,
has
Chris.
to be a packet delay. That's
Yeah.
correct.
Okay.
Okay, and then I can kind of go on and I was probably the first to put a microprocessor in. I worked for Institute for Astronomy. They hired me after the Aloha project. Actually, after the Aloha project, when the Aloha project ran down, Norm talked me into going. Well, he didn't have to bend my arm too much, but he talked me to going with the United Nations to Hungary to teach them about the PCU and repeater. So I spent a couple months there in summer of '76. And at that time, the Aloha project was winding down. And it was a very interesting, very nice time because I actually was privileged and I had the passer from the United Nations and the whole 9 yards. So I got to go over there and have a good time and teach microprocessors and teach radio to the Hungarians there. And
How did Norm get so attached to Hungary?
I don't know. Go ahead, Frank.
I think he had a friend
He
that,
and Joan went to Hungary, I think for a whole semester. I'm not sure. So as a
Invited lecturer. Yeah.
yeah.
Okay. Yeah, he also went to Russia too once, right?
Well, he never stayed there long.
Yeah.
In Hungary, he stayed some time.
Oh, okay. All right, Chris, that sounds really exciting.
Okay. And to go on, about in 1977, Norm invited me to go to Singapore to spread Aloha ground systems there. And there was a national conference there that he was part of and pushing and promoting. And we tried to stir up some enthusiasm about that, but it kind of fizzled out. But we presented the Aloha system and what we did in Hawaii and tried to sell it to various people in Singapore. And also there's some people from Europe there and all over the world were there, which was an interesting weekend. And to go on after that, I was going to say, I was invited to work for Institute for Astronomy, and I designed their 88-inch telescope controller, which I put an Intel 8085 in. And I did a lot of innovative things there. We put the whole board that controlled the telescope was run by an 8085, and we had an LSI 11, which I talked to, which ran fourth to do a lot of their work. And I remember controlling the dome and controlling the moving the telescope and all kinds of stuff. And shortly after that, I was invited to teach at UH, and I taught there for 10 years, microprocessors and so on. And during that time, I went with a startup company, Verifone, in Hawaii, one of the few high-tech companies that started, well, maybe one of the only high-tech companies that started up in Hawaii. And going back to previously, you were asking about why high technology and technology parks and so on didn't happen in Hawaii. Well, it turned out that that time, Hewlett Packard was interested in coming to Hawaii, but the politicians here, the land was so precious to them and so expensive that they didn't want to give up anything here in town. So they put the technology park out in Wahiawa. And they still call it the Technology Park, which houses Oceanic and a few construction companies and so on. And there's really no electronic technology. Well, at Verifone, I worked there for a number of years, and I built and designed a little credit card terminal, which was very commonly used. I didn't build it, but I designed it. Verifone, little square terminal that you ran your card through, which is now obsolete, but it had a Z80 in it.
Oh, cool.
Of course, Zilog, you know all about them. It started up by some of the Aloha people back 50
Oh, yeah,
years ago.
Charlie Bass joined that group. Oh, okay, well, that's very interesting, Chris. All right, any last thoughts?
Okay, well, let me just show you here. See this little, I don't know if you can see this.
No, it's
Out of-
blurred out. Put it by your face, closer to your face. Oh, now we can see it. Yeah, okay.
That is a PCU.
Oh,
Right.
wow. Oh,
It
wow.
cost $8. Built in China. It's got the buffers, it's got the air correction, air detection, radio, everything in it. Only thing it doesn't have is a terminal and CRT and the computer which would control it, which talks to it.
What network is that for?
This is for your whatever you want to use it for. It's 2400 megahertz.
Okay.
It is FSK. Very similar to what we did with the Aloha project.
Cool. Well, they're just 40 years late.
Yep. And also for use it,
Oh, yeah.
if you can see this,
Yeah, yeah.
this is a SDR receiver, software defined radio,
Oh, wow.
and it covers broadcast band to 3000 megahertz. It's got an antenna plug on one side, which you saw, and it got a USB connector on the other side. And just make the comment that USB, of course, came from the idea of Aloha Project 2, can be traced out from networking. And
Sure.
the way the protocols will work on the USB, being able to kind of randomly choose the device and assign it and so on. It kind of all comes back to the technology that was first, I want to say invented, but figured out by the Aloha Project.
Yep. Okay, good. Excellent. Excellent. Okay, Chris. All right. So we've been going for a long time. How about another 15 minutes? Does that seem about okay with people?
Yeah.
Okay, I thought we'd just open it up to some more general questions. You guys have answered most of them already. The only person I haven't heard anything about, maybe you guys could help, was what role Tom Garner had in the project.
Who?
Tom Garner?
Oh, I know them.
Yeah,
Tom was Norm's student at Stanford, and then he went to Cornell, but it was too cold in Cornell, and Norm invited him to Hawaii, and Tom Garner is very he doesn't like to publish, but
Right.
he's one of the most clever people I know. And so in the initial work that the group of us got together, Tom contributed a lot of ideas. But once we had the project going, I don't think Tom involved him very much. Tom
Okay.
Garner is also a surfer.
Yeah,
And
that's
the
what.
thing that people will remember him is that he never wears shoes.
Guys, well, that fits for Hawaii. So that's
Yeah.
Robert, I think
Yeah.
one of the things we haven't talked about at all is the one of the things that fired up around 1972 in the project, of which a significant part of the Aloha project overall was the satellite work, as reflected in the Arpanet satellite system notes, of which I in particular got involved in that fairly heavily in 1972 as part of the project. But I think that was a very significant effort based upon maybe the first satellite system note that I think Norm wrote up. It sounded to me like it got started by Norm stopping at BB&N one day and talking with Dave Walden and Several Weinstein and some other people about, hey, why don't we do random accessing on a satellite or something and use that with an Arpanet, something along those lines, which he wrote there. In any case, that suddenly appeared as a significant effort, which was ongoing. It was all on paper. There was an Arpanet satellite system was never built. The closest thing to it was the Atlantic Packet Satellite Project, SatNet, which has been featured in at the Computer History Museum back in 2007, and that involved it was a very fun effort actually, which involved reservation Aloha being developed at BB&N, and then Larry Roberts developing a more generic satellite reservation system using random access. Both of them used random access, and then we
you were there. You were there at BBN doing this work.
Yeah, after when I left, I'll get to that in a second because that is the fruition and part of some of this stuff. And then in Hawaii, actually based upon initially an idea that Wayne Lichtenberger had worked up then in detail and wrote up another third reservation system. It's called Reservation TMA or whatever it was I called it. But that was a very significant effort, I thought, from my point of view, at least as part of the overall project. It got us very directly involved with a lot of people from Len Kleinrock and his group and BB&N. I don't remember where else. And then it saw fruition in the Atlantic, in SatNet a little bit. In that I left the Aloha project in January of 1975 to go to BB&N, for which they were just firing up the SatNet project, which consisted of taking an Arpanet imp and adding some code to it to talk to the satellite with what initially was a simple slotted Aloha protocol. And they hired me to come to BB&N and pick that up from Andy Retberg and write that module. And so initially we used simple slotted Aloha in the first, let's see, four of them actually, 3 or 4 satellite imps, which were not, after a very initial beginning, were not actually a part of the Arpanet per se. They were embedded within the Arpanet, but routing did not take Arpanet traffic through those links on a Eutelsat channel. So that was the extension of the Aloha channel, if you will, to satellites.
Yeah.
That,
Yeah,
and
I
then
think
went on to then get, it ultimately ended up as a fairly sophisticated reservation scheme based upon mostly on Larry Roberts' initial.
well, did your proposal get implemented?
No,
Oh,
I
okay.
was of course being the guy that was writing the software was also
okay.
to put it in there, but in fact, Erwin Jacobs was leading the multi-contractor effort at that time. It was Bob Kahn had set it all up and funded it, but he turned the technical leadership over to Erwin, who proceeded, and Linkabit, who was his company at the time, had the charter to really work up the final protocol that ended up there. It was somewhat of a group effort, but it ended up being CPOTA and FPOTA, CPOTA being contention-based, priority-oriented demand assignment, very generalized reservation scheme, using slaughtered Aloha for the reservations,
Right. Right.
the Larry Roberts scheme.
Right. Well, yeah, I definitely, by the way, I was able because Klein Rocket donated all the system satellite notes to UCLA. As you saw, I now got copies of all of them, including the ones you did. I definitely saw it as an extension of the ALOHA system project. I mean, why you don't have to worry about hidden terminals if you put the Menehune up into the sky and everything goes up, gets broadcast to everything on the ground. So you get around a lot of problems. And you don't need repeaters. It's like a blessing, great blessing.
And the offshoot commercially in a few years from that was VSATs.
Right.
And VSAT small aperture satellite networks.
But what I saw happen, I guess, was that person who was really allowing this to go ahead, which was Larry, he left then and went to go to that startup, to that company, right? And then
the X25 stuff, yeah.
Yeah, and then what happened is Bob Kahn got all excited about packet radio, which went off to become a 10-year project that had just massive complications and challenges.
Yeah. There was one, by the way, if I take another couple of minutes here.
Sure.
There is an interesting little thing along the way here. Just after we, in 1975, had put in the slotted Aloha and the satellite imps, and we installed one at Eden, West Virginia, and then another one over in the UK, and we're bringing them up and having them talk to each other. Still as part of the Arpanet. And in fact, in that very first, when we first brought them up, we didn't have any restrictions or controls. They just, when we opened up the channel, so we brought them up one evening and had them start talking to each other over the satellite channel, but as part of the overall Arpanet, and but using Aloha. And so as soon as the routing algorithm of the Arpanet saw that via the seldomly sent control packets that, hey, I got a path here, and all pretty good. I got 50 kilobits roughly of traffic path here, as opposed to the 9.6 that was otherwise in existence to connect to the UK. So we were, myself and another person were sitting in the Arpanet control center. They had a little board of lights up on the wall that were blinking and so forth and showing status of each of the Arpanet imps out there at the time. And as soon as we brought it up, those two satellite terminals, and they started passing traffic, all hell broke loose in the Arpanet, at least in the information coming back to the control center. Each imp would send some information periodically to which caused the lights to say, hey, everything's okay here, and the imp is all okay and everything. And suddenly there was this wave of lights going on and off. And the fellow who ran the control center at that time was helpless to go in. He couldn't reach our satellite imps to turn them off. And so, and then of course, once routing decided, hey, well, this is not working very well, so I'm not going to send traffic that way. And then it would settle down again and be okay. And then immediately get back into that state. And so it was oscillating like this until finally he was able to get in there and shut it off. So the bottom line of this was the very first experiment that demonstrated that we needed an internet, because trying to run this within the Arpanet itself with Aloha protocols was a disaster, of course. Anyway, that's my little story.
Well, yeah, that's a fascinating story. Yeah, there were certainly no good flow control mechanisms in the first Arpanet, so I could see how if you were overloading the system, it would just get into non-linear.
Well, routing wasn't prepared. Yeah, routing had certain assumptions about lines, and it wasn't prepared for Aloha. And so,
okay. That's a fun story. All righty. So I was going to just go through. Yeah, thank you for bringing up. I forgot to ask about the satellite, the ARPA satellite system. That's really good because that's kind of what it evolved into. So a few other questions I had for all of you guys. Was how extensive was the ALOHA system? I think there was a terminal in Norm's office. There were some in the lab. There was a community college nearby. I think that had you guys linked to, but that was about it, right?
I think I had,
Yeah, we set up a terminal over at the Windward Oahu Community College.
Okay. And you
And
said they really liked it. They didn't want to give it up.
yeah, they liked it. We went to the repeater on that one, actually.
Right.
Alan and I worked on that. We used a Yagi antenna, directional antenna pointed at the repeater.
Okay.
And
Were there any other installations, any other cities or islands, Maui or
well, we took one or two of the TCUs around to demo. Remember, Alan, didn't we take a TCU down into the Princess Kailani Hotel one time? There was some conference or something there, and we set it up on a table in there. And you remember that?
Vaguely.
Maybe not.
I-
Yeah,
I do remember trying to, almost like we were trying to market this thing.
yeah. I think we're trying to peddle this thing, and it was interesting because you had no direct line of sight inside the building, but you had this standing wave pattern in there, and all you had to do is move the TCU around a little bit, and you had a solid link. You just have to hit a hotspot, and we had it set up on a table right inside this big hall or whatever it was, and demonstrating how we could communicate back to the 360 with it. And then the only other one I think that I know of was the one over at the community college. And then a brief test up to Haleakala.
Right. We're not counting that. Okay, so there were no other permanent installations. How about on the campus itself? Was there, besides Norm's office and your lab?
Yeah, we had a few set up there in Holmes Hall, as I remember.
Okay. Any other memories from anybody else on where they were distributed?
I think I had one from early on in my office down in whatever that section of the campus was, over those bungalows.
Over there, yeah. Was that what you?
I can't remember for sure, but I think I had one. Alan, do you remember, or Dave, whether?
Did we have a TCU back then?
Huh?
You're talking about
back before we moved to Holmes Hall.
Oh,
Well, I never moved to Holmes Hall. I stayed
Oh, that's right.
the duration over in that bungalow. That's what the Lockheed Sioux was, and that's where the radio you were talking about before that was.
Yeah.
I think that radio, by the way, was because one of the original motivations for the Lockheed Sioux was to load up the channel.
Yeah.
Yeah. I'm not sure we ever actually ended up doing that. We did a lot of simulations with it, but I don't remember if we actually put stuff out on the channel from it or not.
Yeah.
That was all in one of those bungalow buildings over there.
So you had one of the TCUs over there then?
Thanks. Pretty sure I did.
Yeah, you probably did.
And then eventually the TCUs were all replaced by the PCUs, or
No.
Oh no, I don't think there's more than one PCU ever built. Was there, Chris?
There was 2 built.
2 built. Okay.
Yes. And I occasionally would have the opportunity to take one home and use it from my home. And one of the interesting things about the whole project there is that to get into that IBM machine, you had a modem, which was a teletype rate, and you had to have a teletype, a big clunky machine. CRTs were like $2,000 or more at that time. And
that would be 20 grand today.
yeah, and going back, there was only one place that you could really get high-speed data to and from, and that was the IBM machine. And that was sought after. I mean, people really wanted to get into the timeshare option and do their programming and store their files in there. And doing it via landline, it's just 300 baud, 1200 baud modems, you have to remember, didn't really come out until 76, 77. That quadrature modulation was late and it was expensive. Dave, you probably recall a lot of that.
Yeah. So it's too bad that you guys couldn't have gotten a giant grant, because you would have been loved by all the students everywhere and all the professors. Oh,
I remember when we did that setup over at Windward Community College, we had a CRT over there, didn't we? CRT terminal?
Yes, I'm sure you did.
Yeah. And I remember these kids have been working from there. They'd been working into the 360 via phone line before that, and just hating it. You know, it was just chunk. And we set that thing up, and these guys couldn't believe it. They just, here's the CRT, and they'd put a query into the computer, and the whole raster just up once, They just what? And that was just a 9600 baud.
Yeah, that was a big step back then. I remember. All righty. So my next question is
anyway, the point is they didn't want to give it up.
They didn't want to give it up. Yeah. Okay. So my next question is, there was this TCU failure light whenever the 3 transmissions would fail, or maybe there was too much noise. How often did that come on and the system would lock at that point? Was that a common phenomenon early on, or just really rare?
We never really kept track of it. I mean, I saw it go off and on, but I don't think we tracked it.
Okay, it wasn't common.
Yeah.
So maybe it was due to like radio car noise or something interfering with transmissions, or.
Well, most likely it was due to your location, because the buildings we were in were steel reinforced. And as Dave pointed out earlier, you moved to a sweet spot, and it worked well. And I remember taking that PCU and moving it around, and we go, you could hear when the radio would go beep, 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 retransmit. And you have to, okay, it's not receiving. We'll move it a little bit. And catch.
Yep, sounds real. Okay. And then you guys ever, I know I've asked you before, and I'm still working with Bob and trying to figure it out, but do you remember anything about Metcalf's visits at all, or him himself, or
Yeah,
you're the person who hosted him first.
well, yeah, I had this, I think it was in 1972, where I had a call to my office one day out of the blue from Bob, who said he wanted to come out to Hawaii and learn about what we were doing. And he did, proceeded to come out and spend some time. I think he was only there for a day or two. So,
yeah. The impression I got, I need to ask him, is, he wrote this paper on controlling the ALOHA, the pure ALOHA, right? Which was the idea that a station would not transmit. If you had Q stations waiting to transmit, the probability of any one coming on was 1 over Q. So that would then result in a nice, instead of getting locked up into everyone screaming at each other, at least it would plateau out. And I'm not sure if he wrote that analysis while he was there, or he did it first and came out and wanted to run it by you guys.
He did make a presentation, I think, that afternoon to Norm and me and probably 1 or 2 other people who were there on something, and showed the and things, and that's my memory of it.
I'll bet you it was this. I'll bet you he did the math. It's not something you could do in a couple of days too, right? And he wanted to see what you guys thought about it, as I'm guessing. And apparently you guys gave him positive feedback. And I mean, later Norm in his oral history said he thought Metcalf had student-itis, meaning he needed to get his PhD done.
Well,
Yeah, I can recall one time where a group came out, I don't know from where, but they had a 6800 machine and they were trying to interface it into the Minahoney. And they spent 2 or 3 days trying to get that thing to work. And I remember going over and talking to them and saying, hey, can I help you with something? I can look at the code or whatever.
This has got to do with Bob Metcalf?
I don't know if it's Bob Metcalf.
Oh, no, this is not. This wouldn't have been. This would not have been Metcalf.
It
No,
was
no.
it was somebody out of the SRI or someplace.
Yeah, that could be. Okay, any other memories on Bob Metcalf though? Frank?
one of the things I think that's significant is that Norm got hold of somehow, and I don't know if he actually eventually found its way, maybe from Bob, into an Arpanet satellite note or not, but was the memo, and Norm references it in that Surfing with Aloha paper or whatever it was. A memo that Metcalf wrote in, I believe it's dated May of 1973. It was an internal memo for Park about changing the name from Alto Aloha, or what you guys were building, or whoever was building then, to Ether, and using the name Ether instead of Aloha, because of this, that, and the other thing, and so forth. So, and then he went on to, it's actually a long memo with some other stuff in there too. That might actually be in one of the Arpanet satellite notes.
So Richard, the memo that Bob wrote inside Xerox, we all have copies of. It was the May. You're right, May.
Yeah.
But you're saying that he somehow Norm saw that memo?
Yeah, I guess he shared it with Norm, because
Sure,
Norm
okay.
referenced it in that 80-something paper that he did for the IEEE publication on surfing.
Yeah.
you
Yeah,
know,
okay.
or whatever it was.
Okay, yeah, it's very possible. I mean, Park was a pretty open place. They weren't confidential memos at that
And
time.
Norm, of course, grabbed onto it because it started off calling it the Alto Aloha.
That's correct. It was Bob originally internally called it the Aloha Alto or Alto Aloha network. It turns out I actually have someone there at Park saved all of his memos, and I actually have 2 memos before that famous May. By the way, he wants to celebrate the 50th anniversary of Ethernet this coming May 22nd. So you guys are all invited. Mark, do you know when the date is yet? Mark Weber?
It is the actual date. So it's a Monday, I believe.
Do we have a date though for the CHM celebration?
Yeah. Bob really wanted to do it on the date, and we said, fine. I mean,
Oh, okay.
Monday's often not the very best day, but we are doing it.
Yeah, May 22nd is Monday. Yep. Okay. Yeah, it turns out that that's when of course, his design wasn't complete then. He didn't have the exponential back off. He didn't know how he was going to control the network. The memo is just very stake in the ground like thing. And actually the first Ethernet, David Boggs would tell you if he was here, wasn't really working until November of that year. So, but anyways, Bob really latches onto that memo. So it's interesting that he showed it to Norm at some point.
I don't know how Norm got a hold of it.
Yeah.
But he did. And
Well, Bob has always been up front, and I think Norm was always happy about that he would attribute. So the next time that Bob came was in January 73 for the 6th Hicks conference, because that's when he presented his controlled Aloha paper, and he added that paper to his dissertation to get his PhD. And does anybody remember him giving the talk? Frank, you were well, I think Norm was the session chair. Frank, I don't know, you may not have been there. Were you there? You were there, Richard, probably.
Yeah, I think Frank was the chair of that.
Okay. Do you remember him giving his talk, Frank, at the Hicks?
No.
Oops, I put Frank on mute. I got to unmute him. You got to unmute yourself, Frank. There we go. Oh, Frank, you're on mute.
No, Frank, you're muted.
You got a
Button on the left side, Frank, at the
There you go.
bottom. There you
Now I'm
go.
okay.
Okay.
No, I don't remember that talk. I could just remember he and his wife came, and Jean gave her a flower, and she asked Jean, "Do you speak English?"
Yeah. So from what we can tell, Bob was only there for these few days in, September or October of 72, the January 73 conference. And then he came I know from his records at Park that he came in October 74 for a 1-month vacation in both Maui and Oahu. And he met with you, Richard, during that time.
Well, he was interacting with a lot of people on the project at that during that visit, because that's when we were putting together the retrospect paper that looked back on the whole project and said what we would do differently and all of that. That was in 74, and he, I remember, was kibitzing that, providing some, inputs to it in terms of observations. Well, you got to do this or that, the other thing in the paper. And also I noticed that around that same time, and later 74, apparently I wrote up my round robin satellite reservation scheme for publication and presentation in 75 at ICC. And I acknowledge Bob for his reviewing of the paper or something before, and helpful comments and all of that. So he was around doing stuff at that time.
Yeah. That was about when he left Xerox, by the way. He left Xerox Park in about 75 and went to.
I have to leave pretty soon.
Okay, we're about done. I think that was almost my last question. So, my second to last question was, how do you guys feel about the 360 being called Kahuna, the IMP being called Menehune, and the user terminals called Kekais? Was that a student did that? Keki, were you guys okay with that?
Well, I thought, for my 2 cents worth, and I think Menehune is an apt name.
Yeah.
Given that there's a lot of similarity in the overall functionality or the role it plays of the Menehune to the Arpanet IMP, which they were both, coming up, or well, the IMP was already up, but so I think and given my understanding of what Menehune is, interpretation of it, that it's kind of appropriate. That I don't think any of us ever used Keiki beyond using it with whoever defined it, and I was given those names to use for that original 1969 paper report. I don't know that we ever used them after that. We certainly didn't say the words much at all. And Kahuna was, again, kind of a nice name for the role of the 360, but I don't think we ever used that, called it that. Menehune did stick.
We only used Menehune a lot.
Yeah, that stuck.
The rest, is Norm's papers.
Okay. And Alan, do you have any memories of these names?
Yeah, of course, if you ask a native Hawaiian, they probably get very offended by how it's used. But I didn't see the names apply the function in the network. I know, looking at IMP, you're taking a physical dimension to say Menehune, because Menehunes are small people. But other than that, the meaning or the people, the Menehune, was not, properly applied, I think. In the Hawaiian culture, there's about 15 different kahuna, and they're specialists in different aspects of their communities, the culture, the belief, the history, and everything like that. And so there is not just one, like a chief of a place. It's not like that. It's a kahuna were specialists in different areas. And of course, keiki, you keep on mispronouncing keiki, so you need to know it's keiki, not keki. But anyway, it's a child, and I didn't see the terminals all being children. But hierarchically, maybe that's the whole idea, was to have the top thing and the middle thing and the bottom thing. So
Yeah. Well, I think in my book I'll probably not copy the illustration that shows that, because since you guys didn't really use it, there's no reason to dwell on it. Okay.
Well, I gotta go. All right.
Okay, Frank, any last thoughts? Frank,
Forget the last message.
last message. Go, Frank. What do you want to say?
Goodbye. Thank you very much for this wonderful meeting. I think you really did a great job. Thank you.
Yeah, well, thank you, Frank, and thank you for your suggestion of having it.
Right.
Yeah,
Thank
thank
you
you.
for giving us the opportunity.
You did a good job. Thank you.
Yeah, they're all thanking you, Frank.
Thank you, Frank. Yeah, thank you. Frank.
Aloha.
Thank you to all of you for this wireless world.
hope I get to play poker with you.
All right.
All right. Any last words from anybody else?
I'll send an email with some follow-up things
Oh, okay,
we'd
Mark.
like to collect and things like that. Thank you so much.
Okay.
Good.
David, do you want to have any last words?
No, it's just a great meeting. Is my last words. I really enjoy seeing everybody again. It's been a few years.
Yeah. Richard?
We had
Richard?
We had a great team. We did a lot. Yeah. And we had
Richard?
fun doing it.
Yeah,
Richard?
I have to agree with
This has
David.
this has been a fun get together.
Yeah. I've enjoyed it. Alan, any last words?
Yeah, I just wanted to add that the timing was good when I left ALOHA Systems to go to GT Hawaiian Tel, because that's exactly when they wanted to start their data communications network. Up to then, it's just been telephony, and so it worked out quite well. But the problem they had was they were debating between circuit switching and packet switching. In telephony, circuit is kind of golden, right? Packets.
You bet.
Packet switching was something they kind of their eyes glazed over when you talk about it.
Yeah.
I think the significant contribution that I made holding my butt was to get away from circuit switching and move over to packet switching.
Yeah.
And so we worked with both Bernack and Newman to bring in packet switching system, and that became the way that we provided data communication services. I mean, we still had synchronous lines for a lot of the networks that the banks and everybody had, but for time sharing purposes, packet switching was the service that was provided.
Okay. All right. Well, we've gone.
Sorry. Hey, sorry. I did think of something I had forgotten. You know, Larry Roberts, he did a paper on that handheld terminal, which was, he said, was partly inspired by Alohanet, of course. Do any of you remember that? Or
Well, it was part of the
Norm-
packet. It was part of the packet radio project. That was his goal for what he wanted. It was like a handheld thing with your fingers like this, and you would actually enter ASCII letters or
Right.
whatever binary pattern with your fingers, and it'd be used by people in the field.
Yeah.
But did that trickle back at all?
No,
to
it was
Alohanet?
it became packet. It was a vision for the future, like for packet radio. But the reality was, to produce the radio, you needed something about this big, a foot long and a half feet wide. So it was just a dream of Larry's part.
Totally. Right, I'm asking about the dreams. Also, Norm is very proud of that phone with a big antenna picture. I guess what I'm saying is, was Norm and Larry both talked in their oral histories quite a bit about that as being a vision of the
That's true.
future. But were you guys aware of that? Was it informing any of what you were doing?
I can speak up and say that I was very aware of it, and Norm and I had a few talks on, not extensively, that, hey, I want a handheld terminal. I want to be able to hold it in my hand. And as it is possible now, the technology just wasn't there.
Oh, yeah.
And it is definitely possible now, and it's done now. In fact, we have now, if you're familiar with what's going on, the latest Apple product actually has satellite communication capability in a handheld phone. So, it's come about now, but we were 30 years ahead of our time. We're behind.
Yeah, no,
our
it's-
time.
Oh, we didn't have the technology back then to implement that stuff at the. I remember Norm mentioning to me that what was coming was cellular radio. And it encouraged me to get involved in it. And the stupid me, I didn't. I wish I had. But Norm's thinking was way ahead of everybody's. He was already predicting cellular radio was going to be a big deal.
Interesting. All righty. Any other questions, Mark?
No, that's good.
Okay. All righty. So anyways, I want to thank all you guys for this great session, 3 hours. I know that's a long time. Realize that the work you did, there's a direct path between your work and today's, networks. It went to Ethernet, and, then it went to various forms of Ethernet, then it went to Wi-Fi, and then, Metro Ethernet. Now the telcos do Ethernet. So there's a direct line path where each step is compatible with the previous step. So you guys helped change the way the world works, actually. And so thank you very much for that.
We'll look
Can
for
I
our
throw-
checks.
What's that?
We'll look for our compensation checks.
Oh, yeah. There are a lot of zeros in it.
Can I throw out a comment? Can I say something real quick?
Sure.
I am thinking that the future is even going to go further now that we have the ability to actually do A to D and D to A at radio frequencies up to 600 megahertz or higher. We can create with a computer a radio image out there, and we can do spread, narrow, whatever you want on top of radio, and put it out there without a modem, without anything. You just put the pattern out there,
Amazing.
and it gets transmitted, and you pick it up on the other side, and with some diversity where you maybe pick a pattern that exists and compare it to the incoming pattern and get the information out of there. You should be able to transfer broadband, multiple copies of it, having multiple transmitters, see them all at the same time with the receiver, pull it in with an A to D, and with the computing power that we got now, pull it apart and go from there. And
We'll
I
be
think
awash.
that's the next thing.
Aren't we basically doing that now?
Well, we'll be awash with so much information. We'll need AI to interpret it for us.
Yeah, well, amateurs are doing some of that with the modern SDR transmitter receivers units, which have been out since about 2010, I want to say, but really taking place now in 2018, 2019. And I've got a pair of them here, and we're seeing China knock off this stuff, and we're seeing these little computers here, the Pi unit. I can't get it up here. You probably can't see it, but
There.
you've seen them, and they're cheap. And there's just a whole lot you can do. The technology is going to turn again. We're going to see another band of changes, and the next link is coming from where
Okay.
we are now.
On that note, why don't we, that's a good way to talk about the future to end this discussion about the past. So anyways, congratulations, great work. I'm glad it's still ongoing, and I look forward to more email exchanges with everybody, and we'll go ahead and stop this session now, if that's okay with everybody.